welcome to lesson number 3. So happy to have you back again. As you can see, today we are graphing in the third and final form of our quadratics. So get ready. Good news, if you were struggling with that parent graph pattern, we don't need it today. Okay, so intercept form is the last and final form, and it looks different than the others, and we graph it differently than the others. So what it looks like is y equals a, we still have an a, times the quantity x minus p times the quantity x minus q. So mind your p's and q's. What you'll notice is that yes, we still have an a value, and yes, it still does the exact same thing. It either opens your parabola up or down, it either stretches, makes it skinnier, or it compresses it and makes it wider. Same thing, except we don't really have to use that parent graph pattern. Okay, this is intercept form. So just to refresh your memory, what an intercept is if I go all the way back up to the top to our parent graph, well, that's not really a good example, but an intercept is where your graph is crossing through an axis. So the x-axis here would be the vertex, also the same for the y-axis there. This one has two x-intercepts at the point 1, 0, and 3, 0. Okay, those are the x-intercepts of the parabola. And this one has two x-intercepts here at 6, 0, and 10, 0, okay? So that's what we're focusing on today, the x-intercepts of the graph. So rather than starting at the vertex and filling in the sides, we're going to start with the sides on the x-axis and then go down to find the vertex. Okay, so this one is completely different than the other two. In that general form, your x-intercepts are the p and the q. But what you should notice about that general form is that it's x minus the p value and x minus the q value. So like we discussed yesterday, in vertex form, when it was x minus the h value is going to appear opposite than what it is because of that general form being a subtraction sign. So basically, rule of thumb, if you have a bubble with a sign in it, it's going to be opposite. You'll see that a lot, okay? Bubble, sign, opposite. Your axis of symmetry, right? Remember that cuts your parabola in half. So it's going to be, the axis of symmetry is halfway between P and Q. So basically, you have your two x-intercepts, P and Q, and you know that halfway between them is the axis of symmetry, and what falls on the axis of symmetry? The vertex. So we're going to be doing a little bit of find the middle. All right, so let's just jump into our first example. Example 5, graph the quadratic function y equals the quantity x plus 1 times the quantity x minus 3. What you should notice is that there's no a value out in front. So what does that mean for your graph? Is it opening up or down? It's opening up because technically the a value is a positive 1. And then is that graph stretched or compressed? Is it stretched or compressed? Neither, okay? So since your a value is 1, it's following that parent graph pattern. It's neither stretched nor compressed, okay? So it's over 1 up 1, over 2 up 4, over 3 up 9. It follows that parent graph pattern, but we don't have to use that. But you should know that that's what it'll look like. All right, so finding your x-intercepts. Inside the first bubble, it's x plus 1. So what is that x-intercept? Negative 1, because technically inside that bubble, it's x minus the p value, which was a negative 1. So again, signs are opposite. Your first x-intercept is negative 1. Your second x-intercept would be x minus the q value. So x minus 3, that q value is a positive 3. So your x-intercepts are opposite. So negative 1 and 3. On your graph, on your x-axis, plot the points at negative 1 and positive 3. You know that that is creating the side of your parabola. It's opening up, so your vertex is going to be somewhere down here. Step B down here says find the x value halfway between the intercepts. Okay, so if you can average those two, so find the value halfway between them, or just count the blocks, going one from here and one from there, okay, you will see that the x value of 1, okay, x equals 1 is your axis of symmetry. That's cutting that parabola in half. So if your vertex is falling on that with an x value of 1, how do you find y? Plug it into your equation. So y equals 1 plus 1 times the quantity 1 minus 3. Okay, order of operations, do what's inside your parentheses first. 1 plus 1 is 2, times 1 minus 3, which is negative 2. 2 times negative 2 is negative 4. So the y value of your vertex is negative 4. So on that axis of symmetry, if you plot a point at negative 4, you now have vertex and sides, and you can draw in a curve. But if you wanted to use that parent graph pattern, you could. So now you have vertex over 1, up 1, because it's following the parent graph pattern. Over 1, 2, up 1, 2, 3, up 4. Over 1, up 1, over 2, up 4, over 3, up 9. You could continue to do that. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if you wanted to fill in other points, you could. And then there is your parabola. Another thing that if you really like that parent graph pattern, before you plugged in the value that was halfway between them, okay, so we're done now, but if you knew that it was following the parent graph pattern, you could have gone in 1, down 1, but you're going into to reach that axis of symmetry. So if I went over 2, I had to go up 4, so if I go into, I'd have to go down 4, and that will also get you to the vertex. It's a little more complex, but if you get it, you get it. If you don't, you don't. So you can always just plug in that axis of symmetry. All right, one more example. 6. We've got the quadratic formula, y equals negative 3, so this time we do have an a value, times the quantity x plus 2.5 times the quantity x plus 0.5. But again, we don't really need to use that a value. It's just telling us what to expect at the end. So we know, first of all, since it's negative, the graph is opening down. And since it's 3, it's going to be stretched. Okay, it's going to get skinnier, faster. But again, with intercept form, you just need your two x-intercepts. So x plus 2.5 means that my x-intercept is negative 2.5. And then x plus 0.5 means that x-intercept is negative 0.5. All right, so fractions, negative 2.5 and 0.5. They're really close, but the point halfway between them would be negative 1.5. Okay, so there's your axis of symmetry at negative 1.5. So x equals negative 1.5. And then what do you do with that value? Well, first of all, remember it's opening down, so you should expect to find the vertex somewhere up here so that the graph is opening down. Plug in negative 1.5 for x, so y equals negative 3 times negative 1.5 plus 2.5 times negative 1.5 plus 0.5. Okay, so y equals, okay, negative 3 times negative 1.5 plus 2.5 is, we've got your 2.5 minus the 0.5 is 2, minus 1 more is 1. And then negative 1.5 plus a positive 0.5 would give us negative 1. So these are all being multiplied. Negative 3 times positive 1 is a negative 3. And then negative 3 times negative 1 is a positive 3. So the y value of our vertex is positive 3. So over here on our graph, on that axis of symmetry, you're going up to positive 3. And there's your vertex. So we're going over 1 down 3, over 1 down 3. Excuse me. If we did want to use that parent graph pattern, if we go over 2 x values from the vertex, normally 2 squared is 4, but that would be being multiplied by 3. So we'd have to go over 2 down 12. So if we did that over 1, 2, we're at the halves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that kind of just goes to show you how skinny this parabola really is. Okay? So there is your finished product there. There are 2 examples in that next worksheet, E and F. They are in Intercept Form. Go ahead and give those a try. I did want to point out one other thing about Intercept Form. If you remember when we were talking about quadratic functions, they are called quadratic functions because the degree is 2, meaning your highest exponent is a 2. But we don't see any exponents in this form. So why is it still a quadratic? Well, first of all, there are 2 x's, okay? And what you should hopefully remember, 7th and 8th period, we'll get to this soon, but my 2nd through 5th period, when you FOIL these 2 bubbles, you're FOILing a binomial times a binomial, you're going to get a trinomial, and your first term will be x times x, which is x squared. Okay, so it is still quadratic. And that's all I got in math for you today. I hope you enjoyed this lesson. We're done with graphing, so that's exciting. And I just want to leave you with a riddle. Shout out to my class of 2020 for this one. If you have one goose, it's called a goose, but if you have multiple, it's called geese, right? Plural form is geese. So if I have one moose, what do I say if I have 2 or 3? What is the multiple of moose? Is it meese? I don't know. You tell me. Okay, have a great day.